Here's a fact that never stops being funny. Dinosaurs aren't extinct. You're allowed to be a little annoyed about that, because somewhere between elementary school and right now, nobody sat you down and told you the asteroid didn't actually finish the job. One branch of the dinosaur family tree made it through. It just got very, very good at being small. And you've probably fed it bread in a park without realizing what you were looking at. This is the story of how a giant reptile became a pigeon, also a hummingbird, also an ostrich, a penguin, and something like 10,000 other things with feathers. Same starting point, wildly different endings. But let's not skip ahead. Rewind far enough and the tape looks the same for pretty much every animal. A molecule that could copy itself, alone in an ocean with almost no oxygen in the air, about 3.8 billion years ago. Scientists call it LUCA. It didn't do much except survive, which turned out to be enough. Everything alive today, feathered or otherwise, is a very long footnote to that one event. Skip forward 2 billion largely uneventful years, and one cell swallows another without quite finishing the job, keeping it running instead as a built-in engine. That arrangement is still humming away in every cell of a bird's body, and yours, and a mushroom's. Cells start clumping together instead of drifting apart, and multicellular life becomes, officially, a thing. 500 million years after that, the fossil record goes off like a firework. The Cambrian explosion, and animal body plans start experimenting wildly. Somewhere in that mess swims a small nothing of a creature called Pikaia, notable for exactly one detail, a stiff little rod running down its back. Every animal with a spine, including every bird that has ever flown, traces back to that rod. Fish show up. Jaws show up. A few fish develop stubby, muscular fins, and around 375 million years ago, start hauling themselves out of the water entirely. Legs replace fins, lungs back up gills, and land has vertebrates on it for the first time in the planet's history. Then, about 312 million years ago, a genuinely underrated invention appears. An egg with its own private water supply built into the shell, letting animals lay eggs on dry land instead of in a pond. That egg splits the family tree in two. One side becomes the synapsids, the mammal line, which is a whole separate video. The other side becomes the sauropsids. That's the branch we're following today, because that's the branch birds are on. Around 252 million years ago, the Permian extinction wipes out something like 9 in every 10 species on the planet, and both branches take the hit hard. But when the dust settles, it's the sauropsid side that comes back swinging. A group called the Archosaurs starts diversifying fast, and pretty quickly they split again into two very different family reunions. One branch heads toward crocodiles, staying low, armored, and patient. The other branch, the Metatarsalans, if you want the full name, heads somewhere much stranger, toward pterosaurs, the first vertebrates ever to power their way into the air, and toward the dinosaurs. A crocodile and a hummingbird, distant as that sounds, are each other's closest living relatives outside their own groups. Nature has a strange sense of humor about family reunions. By around 230 million years ago, one branch of Archosaurs becomes the dinosaurs, and dinosaurs turn out to be, almost immediately, extremely good at being dinosaurs. Within this group, a lineage called Theropods, two-legged and mostly carnivorous, appears. And this is the lineage that matters for the rest of this story. Because you are technically looking at a theropod every time you look at a chicken, and so was anyone standing near a Tyrannosaurus rex. Same branch of the family tree, wildly different family reunions. Feathers show up long before flight does, and this trips people up every time. The earliest feathers weren't built for flying at all. They were simple filaments for insulation, and probably for showing off, the dinosaur equivalent of a peacock's tail, long before anything used them to get off the ground. Small theropods like Anchiornis were walking around the Jurassic covered in this stuff and going nowhere in particular. A few, like Microraptor, took it further and grew flight feathers on all 4 limbs at once, gliding between trees on what amounts to a biplane built out of a dinosaur. An evolutionary experiment that never got a sequel. Around 150 million years ago, a creature called Archaeopteryx shows up in the fossil record with a mix of features that used to baffle paleontologists completely. Reptilian teeth and a long bony tail, alongside feathered wings that could plausibly get it airborne for short stretches. For over a century, it was billed as the first bird, framed in every textbook as the missing link. These days, it's better described as one of many feathered dinosaurs, experimenting with flight at the same time. Not necessarily anyone's direct ancestor, just an extremely good fossil that happened to get found early and photograph well. Through the rest of the Cretaceous, feathered dinosaurs diversify hard. Some fly, some glide, some just decorate themselves, while their larger cousins get on with being enormous and terrifying in the usual dinosaur way. Some of the flying lineages get startlingly close to modern birds. Toothed seabirds like Anchiornis, diving for fish, and Hesperornis, a flightless, tooth-filled swimmer built more like a loon crossed with something out of a nightmare. None of these particular lineages make it to the present. They're cousins, not ancestors. Evolutionary trial runs that looked almost finished and then simply ran out of time. Because 66 million years ago, an asteroid roughly 6 miles wide hits the coast of what's now Mexico. And this is the part of the story where it stops being abstract. Every non-avian dinosaur on the planet dies. Not most, all of them. Toothed seabirds included. Out of that entire sprawling family tree, one narrow branch of small, ground-feeding, seed-eating theropods makes it through. Probably because being small, unglamorous, and able to survive on whatever seeds were left in the ash turned out to be exactly the right skill set for a world on fire. Every single bird alive today, without exception, descends from that one surviving sliver. What follows is one of the fastest evolutionary radiations on record. In just a few million years, those surviving birds split into an enormous range of forms, filling the gaps left behind by everything that didn't make it. Ancestors of today's ostriches and their flightless relatives branch off early, followed quickly by the ancestors of ducks and chickens, and then an explosive burst that eventually produces everything else. Songbirds, parrots, owls, hummingbirds, penguins that gave up flying entirely in favor of becoming extremely competent at swimming. Today, there are more than 10,000 recognized species of bird, more than mammals and reptiles combined. A few features got carried through the entire radiation. Bones that are hollow but internally braced, strong enough to fly on, and light enough to lift. Air sacs threaded through those bones connect to lungs that move air in one continuous direction rather than in and out, which is more efficient than anything a mammal's chest is doing. And part of why a bar-headed goose can fly over the Himalayas while you'd be gasping for air at base camp. A 4-chambered heart runs at a metabolic rate mammals don't come close to matching. And feathers, the same structure that once kept a Jurassic theropod warm, are now fine-tuned into precision instruments capable of carrying a hummingbird backward, or an Arctic tern from one pole to the other and back, almost entirely on the wing. Some of those migrating birds appear to sense Earth's magnetic field directly, using a protein in their eyes that may let them, in some genuinely strange sense, see north the way you see color. Nobody fully understands the mechanism yet. A tern makes a round trip most humans would need serious equipment to survive. And it does it with a brain the size of a grape. Which brings up the other thing bird brain gets embarrassingly wrong. Crows solve multi-step puzzles that stump small children, remember individual human faces for years, and hold what looks a lot like a grudge. New Caledonian crows shape hooked tools out of twigs on purpose, then carry the good ones around for later, which is planning ahead, a skill plenty of mammals don't manage. Magpies recognize themselves in a mirror. None of this fits comfortably with the reptile-brained, bug-eyed stereotype the insult is built on. And all of it comes from the same lineage that spent 66 million years turning a surviving handful of seed eaters into whatever's currently arguing with a squirrel over your bird feeder. So the next time a pigeon refuses to move out of your way on the sidewalk, you're allowed to be annoyed about it with better information. You're not looking at a park nuisance. You're looking at the direct, unbroken descendant of something that watched an asteroid end the world, and, through sheer luck and slightly better feathers, kept going anyway.